In this video, we're going to look at solving equations with more than one variable. So most often, the directions are going to be solving for y, and the examples are going to be solving for y. So let's look at our first example. Okay, so we have negative 2x plus y equals 11. And we want to solve for y. Now solving for y means we want to get y equals, we want y all by itself. Now the reason why we want y all by itself is so we can interpret what the growth is and what the y-intercept is. So we can graph our lines a lot easier, because in a form like this, we don't really understand what's going on in this equation just yet. So we want to solve for y. So, well, the good thing is solving for y and solving for any variable is the same way, or we use the same techniques as we did when we're just solving our normal equations. So we look at, well, we have negative 2x with our y, and that equals 11. So we ask ourselves, how do we get rid of these negative 2x's that are with our y? Well, we just add 2x to both sides. So the negative 2x plus 2x cancel out, leaving our only y. And on our right side, we have 2x plus 11. We just add 2x to this side. So we have our 11 units, and we add on our 2x's. Now this is it. Y equals 2x plus 11. This is our answer. We have our y all by itself. Okay, our growth is 2, and our starting amount is 11. We have 11 tiles in figure 0, and we're adding 2 tiles each figure. Okay, let's look at a second example. Let's say we have 12x plus 3y equals 27. Now again, our directions are to solve for y, which means we want to get our y all by itself. So, well, what do we need to do to get rid of a positive 12x? Well, we need to subtract 12x, or add a negative 12x to both sides. So let's subtract 12x from both sides. So this 12x, we subtract them, they're gone, leaving only our 3 y's on the left. And we have 27, and we're just subtracting 12x. So we have 3y equals 27 minus 12x. Now, we don't really want to know what 3y equals. We want to know what 1y equals. So we want to divide everything between our 3 y's. We want to divide the 27 between our 3 y's and our negative 12x between our 3 y's, because we want to know, what does 1y equal? What does each y equal? So y equals, well, 27 divided by 3 is 9. Negative 12x divided by 3 is negative 4x. So we divide everything by 3. And then I just like to rewrite this with my x's first. So we have y equals, I'm just going to switch these two around, negative 4x plus 9. Okay, so we can see we have 9 tiles in figure 0, and we're subtracting 4 tiles each figure. This is our final answer. Okay, and this is what solving for y is. And there's a whole bunch of different types of examples that I want to make sure we're ready for, so we're just going to keep working through. And as we can see, it's really not too many steps. It's either 1, 2, maybe 3 steps of understanding. We just want to get the y by itself. So let's look at another example. Okay, negative 8x minus 4y equals 24. Again, the very first thing we need to do is get our y's all by themselves. So we think, how do we get rid of negative 8x? Well, I need to add 8x to both sides. Okay, the negative 8x and the positive 8x cancel out, leaving only our negative 4y. And our right side, we have 24 plus the 8x we added on. Okay, now we need to divide everything by negative 4. We don't want to know what negative 4y is. We want to know what each one y equals. We're going to divide everything by negative 4. Now, to help us understand, I know I didn't do it in the previous example, but to help us understand, I like to just draw division by negative 4. This clues in that we need to divide everything by negative 4, because we have negative 4y. So negative 4y divided by negative 4 leaves us with the 1y that we want. That's why we divide by negative 4, because we want y all by itself. 24 divided by negative 4, it's negative 6. And 8x divided by negative 4 is negative 2x. We divided everything. It's very important that we divide everything by negative 4. And again, I'm just going to switch these around. So like my x's first. Y equals negative 2x minus 6. Negative 6 tiles in figure 0, and we're subtracting 2 tiles each time. Again, we want it in this form so we understand what's going on in this equation, what's going on with this rule, and so we could graph it more easily. Okay, again, let's just look at some more examples until we get very comfortable with this. Let's say we have 3x plus 5y equals 30. Same thing, I want to get y all by itself. So what do I need to do to get rid of my positive 3x? Well, I need to subtract 3x from both sides, or add negative 3x to both sides. Okay, 3x minus 3x is gone, leaving only my 5y, and I'm just subtracting it from the other side. This is actually a very easy step, okay, because there's nothing we're really doing. All we're doing is moving the positive 3x on our left side to become a negative 3x on the right side. Okay, now I'm dividing everything by 5. So I don't want to know what 5y is. I want to divide everything between my 5y's. So I want to know what each y equals. So we divide everything by 5. Well, we're left with y equals. That's why we divide everything by 5, so we want to know what each y equals. Now 30 divided by 5 is just 6. Okay, this is a division. Now here, we just want to make sure we're comfortable with this. Okay, we're doing negative 3x divided by 5. Now we know that we can't divide 3 by 5 and get a nice whole number, but we're also aware that we are in 8th grade. We're okay with fractions. We're okay with decimals. And the reason why we show this division like this, divided by 5, is because we understand that division and fractions are very similar. They actually mean the same thing. Fractions mean division. So what we could do is we could cover this up, and we notice this is the fraction negative 3 over 5. Okay, so we're just dividing by 5. Okay, we could do negative 3 divided by 5 and get a decimal, but if we just understand what we're doing, we could just leave this as the fraction negative 3/5 x. Okay, because negative 3 divided by 5 is just negative 3/5. It's really nothing harder than this. So again, I'm just going to switch these around. I have y equals negative 3/5 x plus 6. Okay, so now I'm going to give you a couple examples to try. Okay, there's the first one. There's the second one. So try these two easy examples first by pressing pause and then pressing play when you're ready to check. Okay, so our first one, again, we just want to get rid of the positive 2x that are with our y term. So I'm going to add on negative 2x to both sides, or subtract 2x from both sides. And I'm going to get y equals 19 minus 2x. Or I'm just going to switch this and say y equals negative 2x plus 19. Okay, I'm already done because I just have my y by itself. We have 19 tiles in figure 0, and we're subtracting 2 tiles each time. Okay, in our right example, I want to add 6x to both sides to cancel out with my negative 6x. So get 3y equals, okay, 6x plus 24, or 24 plus 6x. And now I divide everything by 3. And I get y, because I want to know what each y equals. So y equals 2x plus 8. Okay, we have 8 tiles in figure 0, and we're adding 2 tiles each time. Okay, now try these examples. So let's say we have 14x minus 2y equals 20, and 4x plus 7y equals 35. So press pause, try these, and then press play to check your answers. Okay, our left example, we want to add on negative 14x or subtract 14x from both sides. We have negative 2y equals 20 minus 14x. We're careful to keep this negative because we have a negative 2y or minus 2y, so this stays negative 2y. And now I want to divide everything by that negative 2. So we get y equals 20 divided by negative 2 is negative 10. Negative 14x divided by negative 2 is positive 7x. I'm just going to switch these, so we get y equals 7x minus 10. We have negative 10 tiles in figure 0, and we're adding 7 tiles each time. It's why we want it in our y equals form. In our right example, first thing I need to do is get rid of my positive 4x that are with my y, so I'm going to subtract 4x from both sides. So 7y equals 35 minus 4x. Divide everything by 7. So we have y, because we don't know what each y is, so each y equals 35 divided by 7 is 5. Now I'm not afraid here. We have minus 4x divided by 7. I can't do 4 divided by 7 evenly. Okay, we don't really want decimals, so we're going to leave it as the fraction, negative 4/7. So we have minus 4/7 x. So we have y equals negative 4/7 x plus 5, just to switch it to put our x term first. And some of you might realize, why don't we just put the x term first to start with? And that's an excellent idea that we should really do. Okay, so now let's look at what if we're not solving for y. Okay, but the idea is the same thing. Let's say we have an equation that says solve for m. And we have 3n minus m equals 5n plus 21. Okay, this is really the same thing. Whenever we get solve for a variable, we just want to get whatever variable it says to solve for all by itself. And we want to get everything else, whether it's just a number, whether it's another expression, on the other side. And our steps don't ever change. We're still allowed to use the same techniques. So I notice we have 3 n's on the left, we have 5 n's on the right. Okay, so we have 3 n tiles on the left, 5 n tiles on the right. Okay, it doesn't matter what variable we have, we still think through it the same way. So I'm going to subtract 3n from both sides. Okay, 3n, I take away those 3 n's and I'm gone, left with my negative m. 5n minus 3n is 2n, and I still have my 21. Okay, nothing different. Now, I have negative m equals 2n plus 21. Well, I don't want to know what negative m is. I don't want to know what the opposite of m is. So I'm going to divide everything by negative 1 or take the opposite of everything. Both do the same thing. So the opposite of m equals 2n plus 21. So that means regular m equals, well, the opposite of 2n is negative 2n, and the opposite of plus 21 is minus 21. So I take the opposite of everything. Okay, and this is the same as dividing by negative 1. Okay, so we have a negative 1m here. So 2n divided by negative 1 is negative 2n. 21 divided by negative 1 is negative 21. Or we could just think, I just want to take the opposite of everything, because the opposite of m equals 2n plus 21. So regular positive m equals negative 2n minus 21. Okay, so why don't you try this example. So solve for p. So we could have 3p plus 2 equals 4r plus 14. Okay, so press pause, try this one, and press play to check your work. Okay, solve for p means we want to get p all by itself. So we notice what's with our p. We have a plus 2, so I'm going to subtract 2 from both sides. Okay, so this leaves me my 3p on the left, and it equals 4r. Well, 14, take away 2, because we're taking away 2p, or 2 units from each side. We get plus 12. Okay, now I want to divide everything evenly between my 3p's. So I'm going to divide everything by by 3. So I get P equals, well, I know I can't do 4 divided by 3, but again, we're not worried because we just know that we could cover everything else up, and then we see we have the fraction 4/3. So we have 4/3 r plus 12 divided by 3. We could do this division, so 12 divided by 3 equals 4. So we divide everything by 3. And this is our answer because we have P all by itself. Okay, so if you need more examples like this, please refer to the textbook or some of the other online resources.